Hey guys, so let's finish those notes that we were working on earlier tonight. Um, so if I remember correctly, we should be starting on this one. Okay, so notice that we need to have log equals a number, but we don't have that. We have that 8 in the front. And that 8 is attached by multiplication. So we're going to undo that with division. So we're going to have log 4 w plus 6 equals 3. Now we have log equals a number, so we can do our e to convert that. So 4 cubed equals w plus 6. 4 cubed is 64. And then we subtract 6 from both sides, which gives us a 58. And if we were to check that, we would see that it works. Okay, let's look at this next one. So this one, we don't have anything on the outside of it. So we have log equals a number. So remember that that's an understood 10. So we can go make our e. So 10 to the 1.4 equals t plus 18. You're more welcome to go figure out what that is. I'm just going to wait. So I'm going to go ahead and add my 18. So we get 10 to the 1.4 plus 18 equals t. So if you type that into your calculator, I had to go grab mine. We get 43.119. Okay, now sometimes in the book or in your homework, they ask for a solution set. That is what they are referring to. Okay, let's go look at this G. So we definitely don't have a log equals a number, but if you think of it, we can move this to the other side. Oops. So we have log 2x plus log 2x minus 2 equals 3. So now we're adding logs, so therefore we can multiply them. And I'm going to go ahead and multiply like we've been doing in class. So x times x is x squared. X times negative 2 is negative 2x. So now we have log equals a number, so we can make our e. So we're going to have 2 cubed equals x squared minus 2x. So notice we have an x squared, so we're probably going to have to factor, leave that positive. So I am going to go ahead and move this over here. So we get 0 equals x squared minus 2x minus, and then 2 cubed is 8. So what times what gives us a negative 8, but has a difference of a negative 2? Hopefully you were thinking negative 4 and positive 2. So we would do x minus 4 equals 0. So x equals 4. X plus 2 equals 0. X equals a negative 2. So if we plug 4 in, we are fine on both of those. But if I plug in a negative 2, it will not work. Okay, it won't work actually on both of those because we would have log of a negative number. So that is the only one that we can have. Okay, so like I mentioned in class, this is actually just a duplicate. So let me go compare. So this one was on the front page. This one is on the front page. This one and this one are on that front page. So the only other one that wasn't on the front page was this one. So we're going to jump down to this E. And so notice this is still like a log equals a number, but we can't make our E's. We don't have logs on both sides. So how do we undo a natural log? Well, we E it. So we are going to E both sides. So x equals e to the 2.4. So we would just want to type in the calculator e to the 2.4. So x would be approximate 11.023. So again, kind of like that other one, this would be like the exact, and then this over here would be like the solution set. Okay, so that kind of knocks that out. Let's see what the next page is. Is this the last page? Yeah. So we have one word problem for this one, and it says, on August 31st of 1854, an epidemic of cholera was discovered in London, England, resulting from a contaminated community water pump. By the end of September, more than 600 citizens who drank the water from the pump has died. The cumulative number of deaths, D of t, at a time of t days after August 31st is given by that formula. So the first thing that it wants us to do, probably do this first one in pink, is determine the cumulative number of deaths by September 15th, and then round to the nearest whole unit. So it's wanting us to know the number of deaths. So that is D of t. Okay, I'm actually going to rewrite the formula real quick. Okay, so September 15th is 15 days after August 31st. So we're going to plug in 15 for t. So all you got to do is go type that into your calculator. So we would have about 534.6 deaths. So we'll say 535 deaths. And if you look, and that looks like it could be about right. Okay, so here's B. So approximate how many days after August 31st did the cumulative number of deaths reach 600? So that means now, let me redo the formula. So now we're actually talking about D of t because we want to solve for t. So this would be 600. And just like we did in class, we're just going to work our way through getting solving for t. So what would I need to do first? Hopefully you said subtract 91. Okay. Hopefully the next thing you said that we would need to do is divide by that 160 because that natural log is trapped. Okay. So I think I'm not going to get that started in my calculator. So 509 divided by 160. So the decimal's not too crazy. So I think I'm just going to go ahead and write it 1 out, all the way out. We just don't want to have any round off error. Okay, so this t is trapped by natural log. So we know that e will undo that. They'll cancel each other out. So we're going to have an e to the 3.18125 power equals, and those cancel, so t plus 1. So therefore, to get t by itself, we just subtract 1. So t is going to be equal to e to the 3.18125 minus 1. So I'm going to hit my E button on my calculator to my answer power, and then I'm going to subtract 1. So we get T is approximate 23.077. So we could just round down if you want, 23 days. My statistics brain wants to go to 24, but we will go with 23. Okay, so that is the end of that. So we actually made that we almost got through that in class today. So I'm going to put these up. And let's go look at that 9.7. So 9.7 is going to be us just going over some word problems. Okay. Let me see. Use that right there. Yep. Okay, so here we are. So the first thing that they wanted us to do is just practice solving for different variables, meaning this first one wants us to solve for D. So I'm just going to highlight that D. So kind of like what we've already been doing, we're going to work our way to solve for that. So the first thing we would need to do, and hopefully you said it, is subtract 23.5. So we're going to have whatever S is minus 23.5. And that cancels, equals 2 log. I might just go ahead and put that in green. D. Okay. So then remember, we're working our way to that D. So how is the 2 attached to that log? Hopefully you said multiplication, and we undo that from dividing. So we're going to have S minus 23.5 divided by 2 equals log, and then of D. Okay, so we're almost there. How do I undo a log? Well, remember, log has a base 10. So if I take this to that 10th power, we will be able to cancel these out. So that means the D that we've been looking for is 10 to the S minus 23.5 divided by 2 power. Okay, so let's look at this next one. So notice on this one, we are solving for X. So we have 3en to the X minus T equals 4.2. Okay, so first thing we need to do is add this over, because we're going to start working towards this X. Okay. So we got to get the E exposed. So we got to get to the E, so we need to divide. So we're going to have E to the N X equals 4.2 plus T divided by 3. Now the E can be natural logged so that those cancel. So we're going to have N X equals natural log of 4.2 plus T divided by 3. And then for our last step, we're going to divide by N. So X will equal natural log of 4.2 plus T divided by 3 all over N. Now that looks a little crazy. So what I could do is also change that to 1/n times natural log of 4.2 plus T over 3. So either answer is fine here. Okay. Okay, so let's go look at the next thing. Sorry, accidentally messed up on that. That should be 9.7. I hate it when I miss those. So now we're going to create models of exponential growth and exponential decay. So notice the formulas that we're using are very close to the continuous formula. Okay. Notice the y sub naught is the initial value at time 0. And then over here, notice it's the same thing, but it says for exponential decay, our constant k will be negative. So basically in these formulas, you have to try to figure out what that constant is going to be. So a carbon-14 has a half-life of 5730 years. Write a model in the form of this. Now, my T didn't print. I hope your T did. I'm missing my T right there. Notice in this formula, though, it already shows the negative right there. Because a half-life means that it's going to be decaying. To represent the amount, the QT of carbon-14 remaining after 10 years, of T years, oh my gosh, if no additional carbon is ingested. So I want you to think about what's happening. So let me rewrite the formula. Okay, so I want you to think about it like this. A half a life means I don't know what it starts with. So remember how they said this y sub naught is the initial value. That means this q sub naught is going to be. This is my initial value. I just know that my final amount over here would be half of that because the carbon-14 has a half-life. So kind of like the conversation we had in class tonight about the, if I am using this formula and I say I want to know how long something doubles and how we wrote it like this, or something triples, you can write it like this. The half-life is kind of the same thing, but I'm going to put a half there. But when I do this, I also know what my time is because it takes 5,730 years for it to lose half of its life. So if it had 100 carbon-14, then a half-life in 5730 years, it would be down to 50 and so forth. Okay, so this is just me trying to relate it to what we also looked at tonight. So if you notice, these will cancel. So you're left with 1/2 equals e to the negative. And of course, we don't write things like that. So I'm going to flip-flop it. Okay. And so now the e is exposed, so we can do natural log. So we're going to have natural log of 1/2. Those cancel. Negative 5730k. And then to divide by that, we will get our k. Oops, I guess I should have left it right there. Choop, choop. So natural log of 0.5 divided by that negative 5730. So, now I might just go ahead and write that over here. So k equals, now some of you guys might have gotten this, and then, oops, I don't want to use that one. And then an e to the negative 4 in your calculator. This is just, I'm going to go ahead and change that to a 1. This is just scientific notation. So that means negative, we got to go to the left 4 times. So 1, 2, 3, 4. So that's 1, 2, 3 zeros. So k is equal to 0.000121. So our formula would be negative 0.000121 t. Okay, so part B says an archaeologist uncovers human remains at an ancient Roman burial site and finds that 76.6% of the carbon-14 still remains in the bone. So they want to know how old the bone is. So it's kind of the same thing. we have 76.6% remaining. So instead of half remaining, we have 0.766 of the q sub naught, and then equal to the q sub naught e to the negative 0.000121, and we're trying to find the time. So we cancel those out. We're kind of just going to solve it that same exact way. And also kind of like what I talked about in class, like you were going to see this over and over. So we're going to have natural log of 0.766 equals negative 0.000121 times t. And then we are going to divide by that. So you get approximately 2203.7. And it says round to the nearest hundredth of a year. So that would be about 2,200 years old. So pretty old. Okay. Okay, and if you think about it, it wasn't quite half, so it couldn't be the 5730 years. So, okay, so let's go to number 4. Okay, so number 4 says, suppose that at 19 years old, you win 100,000 playing the lottery. If you would like to have $1 million when you retire at 67, determine the average rate of return for continuous compounded. So that is your A equals PERT. It's just that we're trying to find the rate. So let's see. You're playing 100,000. So that means that is what we are starting with. So that's my P. So, okay. You would like to have $1 million. Oops. So that's my A. Equals E. We're trying to find the R. And then this last one, you're 19 years old when you get it. You want to retire at 67. So 67 minus 19 is 48. Okay. So just like before, first thing we're going to want to do is divide by the 1,000, which gives us 10 equals E to the 48R. And then to undo the E, we are going to want to natural log both sides. And then divide by the 48. So R equals natural log of 10 divided by 48. So 0.04797, so 4.8%. Okay, we got one more type to look at, and this is the logistic growth model. So A, B, and C are positive constants. Okay, so here's the general formula that you're going to see. Notice your blue line is this, and it eventually levels off to some value of y. It's going to get close to something, okay? And as you can see, it's actually trying to show you that it's going to average out to that C. And I think that's also down here. In this form, we can see that for larger values of t, the A over the EBT approaches 0, and the function value y approaches C over 1. And so that's what you can kind of see right here. you have a point of inflection in the middle, so the rate of change is increasing right here. But then the rate of the change will start to decrease here. It's going to start slowing down. So it's a little bit faster here, and then it's going to switch. Okay, typically with these type of problems, you'll always be given some type of form, and then you'll have some picture for it. Okay, not all the time. Sometimes it might just be the equation. So we're talking about the population of Los Angeles, and the P of T is in millions, can be approximated by this function. T is the number of years since 1900, so we got to be very careful. So over here, this is the number of years since 1900, and then this is the population on this side. And then please remember it's in millions. So the first one says evaluate the problem for 0. So that just means we need to go plug 0 in. So 3.194 all over 1 plus 14.589 to the negative 0.052 times 0. Okay. So you can type that all in, and you would get, let's see, 3.194 divided by, I'm going to put parentheses, 1 plus 14.589 e to the negative 0.052 times 0. And we get 0.204888. Please remember that this number is in millions. So the next part says interpret it. Okay, so that means in 1900, there was, now let's think about that. Let's multiply that times a million. So that means there was 2004, 888 people. Okay. Use this function to approximate the population in January of 2016. So we have 2016 minus 1900. So this means 116 years later. Okay. So we're just going to use the same equation, but plug in 116. So 3.194 divided by 1 plus 14.589 e negative 0.052 times 116. I got 3.08592. Okay, and of course this would be millions, and this was for LA population. Okay, the next question, it says, what is the limiting value of the population? So basically, where is this starting to level out at? Okay, so remember what it says. And the function of the y value for large values approaches c over 1. And then c is located right here. Okay, so I'm just going to rewrite the formula. So 3.194 over so remember that's a negative, so I can actually flip that and put it right here. Okay, so we have, so all I did was flip that because of the negative, because I just think it would be easier to explain. So we have this fraction, okay? So we have 14.589 being divided by, oops, I left my t off. You guys were probably screaming at me. Okay. This right here, as I plug in the values for t, so as we go higher and higher and higher and higher, this value right here goes to 0. Okay, so like for instance, if I take 14.589 and I don't know, let's divide that by e to the 0.052 times, I don't know, 1 and a bunch of zeros. So I'm just pushing a bunch of zeros. Well, it gave me an error because I did too many. So let me go take some of those off. I took off some of my zeros. Okay, so as you can see, I get 0.08. So the higher that t value goes, and that was for 100 years. I had to take out my zeros because my calculator gave me an error, but it did let me put in 100. And so I get 0.080. That is going to go to 0. Well, if that whole thing is going to 0, well, then I'm practically getting 3.194 over 1. So therefore, my limiting value would be this right here, but of course also in millions. Okay, so at the end of the day, remember your C value will be your limiting value because this term goes to 0. Okay, let me know if you guys have any questions. I am here to help you. Message me on Remind, email me. If not, I will see you guys Monday night. We will go over the test review. Okay, have a good day.